Hi, I'm Kyle Cordes, and I'm going to talk a little bit today about my use of Prolog. I've actually told this story 20 or 30 times, either in person or in various talks and so on, and I thought I should finally go ahead and get it on my website, so maybe not have to tell it in person too many more times. So I used Prolog a bit back in college, back in the early 1990s, and really set it aside, hardly thought about it, probably didn't use it at all for a decade after that. And then around 2004 or so, working on a project for a long-term Oasis Digital customer, we came across this very unusual request from a customer. This was for a sort of ERP flavored system. And what they wanted was to be able to specify these rules, these high-level, very declarative sounding business rules, where they said, if this happens, then do that. And many of these rules were hierarchical or recursive in the way they were described. So they were not readily definable as an if-then about a single record or a few records, but they're about pattern matching entire patterns across many kinds of data in the system. Where if this happened, do this. Well, I thought about this a while and realized that it would actually be a pretty substantial amount of work to implement. It's the sort of thing where maybe in a week you'd have something working, but we would very likely spend many, many weeks getting it working just right and getting it working at the kind of scale they needed, which is tens or hundreds of thousands of records to sift through looking for these patterns. With some more thought, I realized that I could actually solve this problem in Prolog very easily. So we kicked that around a while and ended up doing that. We thought, well, it'll probably take a lot less time in Prolog, and even if we fail, we'll understand the problem better. Well, it turned out that we actually solved the problem and had a working solution in about 1 day of work. That was a really spectacular result for us and for our customer. They were very happy, they got what they wanted, and it more or less was perfect the first time. We might have made some very minor tweak, but it did something very close to their request, because their request had been fairly specific, pretty close to their request, essentially as we delivered it. That's a big win when you're a consulting firm and you can deliver that for your customer. To talk about how the solution works, we used a somewhat primitive, ugly solution that involved a batch export from the data in this running production system into some text files in a Prolog compatible format. They'd get loaded into a Prolog implementation, and then they would get the Prolog system would do the work, and then the result would be exported back out to text files, which would then be imported back into this production client-server database system. That whole process took a few minutes, and then it ran every few minutes. And so roughly speaking, this system was lagging maybe as many as 5, 10, occasionally 15 minutes behind real time. But for the purpose of this requirement, that was actually almost indistinguishable from real time. In other words, the system wasn't being used to make minute by minute decisions. It was being used to make hour by hour decisions. And so this minor delay that they never even noticed, and it wasn't worth any additional redesign to somehow get that 5 to 15 minutes down to be 30 seconds. From doing this project, we really were able to illustrate some really important lessons in software design. Firstly, that declarative solutions are inherently much better than imperative solutions. You say much less and get much better results when you can use a system, use infrastructure that lets you be declarative instead of imperative. I think we're seeing that spread through the industry now more than ever before with things like functional programming, that sort of thing. Next, thinking really matters. You should be eager to try coding something, but you shouldn't be eager to code your production solution right now. Be willing to try a couple of things. Be willing to think for a while to come up with a really good design that will build on the right tools and get really great results. So I'm greatly in favor of iterative design, iterative implementation, but that doesn't mean you shouldn't think. You should think. Nextly, the sort of obvious lesson, choose the right tool for the job. This was clearly a much better tool for the job than writing a large amount of SQL or a large amount of procedural code. Prolog was, in retrospect, just about as right a tool as I could possibly imagine for this job. And then lastly, when you have a big problem, you also have a big opportunity. We could have seen this only as a problem and tried to talk the customer out of wanting what they want, but instead we saw it as an opportunity to go find a way to give them what they wanted. And that turned into a win for everybody around. Thanks for listening, and you can read more of what I have to say on my website.